So the claim today is that every n by n checkerboard with one square missing can be tiled using Triominoes, which is this red L shape here, if n is a multiple of 2. And so this is our base case, right? If we have a 2 by 2 board with some square missing, we can just plop an L triomino down like so. And notice it doesn't matter at all which square is missing, right? We can just flip it and we could have it in the bottom left or the bottom right or wherever. And so now, just to help us get this here for a moment, let's look at the case when we have a 4 by 4 grid with one square missing, right? We can just look at the 2 by 2 grid where that square is missing. So in this case, it's the bottom right guy. And then we're back in our base case, right? We can just plop one in there. Doesn't matter which one's missing. And then you might be like, okay, but what do we do now, right? So we're just going to do this here, right? This is a pretty simple tiling. And so our induction hypothesis will be to assume that any 2 to the k by 2 to the k checkerboard with one square removed can be successfully tiled. And so we just want to show that our claim holds for 2 to the k plus 1. And so we have this checkerboard here, right? Where the key insight that you saw in the last case was that we can just divide our guy into 4 sections. That's the main idea here. And then we have 4 2 to the k by 2 to the k sections. And notice one of those guys is already missing a tile. And so that's one down by our hypothesis, by our assumption. And so you might be like, okay, we can't use our assumption again though. The other guys, they're not missing a single tile. And that's the trick. This is the main idea here. You can just add a triomino in the middle and then effectively those other guys are missing a square as well. And so by assumption, we've just proven our claim for any k. And yeah, we're done.